Hey guys, let's talk about this information for each of these problems for 1, 2, and 3. The domain and the vertical asymptotes are both going to come from the denominator of the function. The x-intercepts are going to come from the numerator. The y-intercept is going to come from plugging in 0 in place of x and simplifying the number after that. To determine if the function has a horizontal or a slant asymptote, you have to compare the powers in the numerator and the denominator. If the powers match or it's bigger on the bottom, there is a horizontal asymptote, which is going to be in the form of y equals a number. And if it's bigger on top by 1 degree, there's a slant asymptote. For problem number 1, since we have matching powers on our variables in the problem, we're going to have a horizontal asymptote, and the equation is going to be y equals 1, because the coefficient of x is 1, and the coefficient of this x is also 1, and 1 over 1 equals 1. To find the equation of a slant asymptote, you want to use division. And if the denominator is in the form of x plus or minus a single number, you can use synthetic division, which is really handy. We only need the quotient for the slant asymptote equation. We don't need the remainder. So our slant asymptote is going to have the equation y equals x minus 2. Now I want to talk about the change of base formula for logarithms. And this is really important for us because the calculators we're allowed to use on tests do not evaluate logs that are not base 10 or base e or the natural log. So in order to evaluate log base 13 of 114, you'll need to use that change of base formula. So it's going to be the log of the argument over the log of the base. So it's the log of this number here over the log of this number here. So log base 13 of 114 can be found by plugging in log 114 divided by log 13 into your calculator. The next thing I want to talk about is converting logarithmic equations into exponential ones. So remember that if there is no number given underneath the log here, that's the common log, which is base 10. And the logarithm is the exponent. So whatever expression is equivalent to the log, that is what our exponent is going to be. So we have base 10 to the power of x equals the number 27. And converting an exponential equation into a log, we have the base 3 raised to the exponent t equals the value 14. So the logarithm is the exponent. So since the exponent is t, that's what the logarithm is going to be equal to. And the base is 3. So we have log base 3 of this value here equals the exponent.